Example number 3 out of our textbook. We are asked to describe how to obtain the graph of a given function when it's written in the form g of x is equal to x raised to the n with the same power of n. Sketch the graph by hand and then support it with a grapher. So let me explain what they want us to do. We've got f of x is equal to 2x to the third power. So what that means is when I go to graph f of x, can you guys see the orange? Okay. When I go to graph it, it kind of looks like this. Now based on what you know, what do you think stretching that by 2 will be? Well, I'm going to pick 2 points on the line, this point here and this point here. By multiplying it by 2, we're taking whatever that y value is and making it twice its value. So assume that this is negative 2. Well, when I multiply negative 2 by 2, it becomes negative 4. And the same here. Now 0 times 0 is just 0, so my graph should look like this, right? And so we'll call that one, we'll just call that one g of x is equal to 2 times x cubed. So I've sketched it by hand and we should see the transformation. So for this one I'm going to use my other graphing calculator that's on my website. And just so you can see the transformation take place, sort of. So just take a second. And give me a second here. So I'm going to graph 2 times x raised to the third. Oh wait, let's do the parent function first, right? X raised to the third. And so now what I want to do with that, whoops, I gotta delete it. X raised to the third. And then if I come down here, I can select graph. Notice all the cool things it gives me the option to do. Find the domain, find the degree, find the range, all that stuff, leading coefficient. But we just want to graph it. So I'm going to hit answer. And then it's going to graph it for me. So here's the graph. Okay. Now this is what I was talking about. See this point here, 1, 1? If I multiply the y value by 2, I should have a point 1, 2, right? So let's graph the second one. Okay. Now if I just plug this 2 in front of it, and now I graph it, oops, I gotta hit the button. Notice that the point is 1, 2 now. Do you guys see the difference between the two? So I just stretched that vertically by a scale factor of 2. And that's all we were supposed to do. Okay? So now let's go back and do part B because it gave us 2 equations, and we'll do part B on the graphing calculator. So part B wants us to do the same thing with f of x is equal to negative 2/3 x to the 4th. Alright, so what we need to do is we need to think about the second graph. Actually, I'm just going to do a second sheet of paper on that. So we're given f of x is equal to negative 2/3 x to the 4th. And so the first thing that I probably should do is think about g of x raised to, or is equal to x to the 4th. So when I go to graph this, this will kind of look like a parabola, except it'll stretch out a little bit. So let's graph it in our calculator, just for the fun, to see if there's a difference. And so I'm going to clear these out, and I'm going to say x to the 4th and graph it. and it'll look like a stretched out parabola. Let me get in and do a standard view. And so it looks kind of like a stretched out parabola. Like this. Okay, and I probably should have used orange, so we'll use orange on that. So that's g of x. Now what's that negative 2/3 thing going to do? Does anybody in here know? Well, forget about the negative. What's the 2/3 going to do? Yes?
It'll shrink the function by 2/3.
It'll shrink the y values by 2/3. So this point here would be about 2/3 down the way. But what is the negative sign going to do to the y value? I mean, what is the negative sign going to do to the y value?
Make it negative.
Yeah, it'll make it negative, but what does that do to the graph, Dana? It should flip it down. So instead of having the 2/3 point here, I'll have the 2/3 point here, and here, instead of having 2/3, I'll have 2/3 here. So when I go to graph this, my graph will look similar, but it'll be closer to the x-axis. Won't be that much of a difference, it'll be hardly noticeable, but f of x should graph like this. Okay, so let's plug that in and see what it does. Now, Mr. Adams knows this because I'm a math teacher, but the truth of the matter is that people who kind of do this sort of thing for a living, they look at the graph, they automatically know what function will have that shape, and then they fit the computer model to it. Or usually it's used, nowadays we use computers. They used to do all this sort of thing by hand, which is fascinating if you ask me. Okay, so now let's see what we've got. Yep, not much of a difference, but there is. Okay. And I could prove that to you because watch this. If I plug in x equals 1, we're going to raise 1 to the 4th power. So on my parent function, I've got y equals 1. But now if I hit x equals 1 on the second function, I get 2/3. So let me show you this in the table of values because this is kind of cool. So this is my first function, the parent function, x to the 4th. This is the second function, negative 2/3 times x to the 4th. And what you'll see here is 2/3 of 81 is 54, and then we have the negative of it. You guys see that? Just like 2/3 of 16 is 10.67, and then you take the negative of it. Okay? And so that's all we're doing is trying to do that graphically.